Namaste student, this is Sanjay Nath. Today's session is on landforms of the earth, chapter 5, standard 9 ICSE. In this chapter we learn about different types of landform that take shapes on the earth crust. Now we'll first understand what are landforms. Landforms are mainly created by natural forces. These forces are mainly categorized into two categories. These forces are inside and outside the earth. They can change the shape of the earth surface, mainly due to the internal forces, tectonic movements, and external forces called gradational force. Both the forces shapes the earth simultaneously and they create remarkable landforms on the earth crust. A landform is a natural feature of the solid surface of the earth, mainly mountains, plateaus, and plains. Now we'll understand in detail how these two forces act simultaneously and create remarkable landforms. As you know that tectonic forces are internal forces, for example, earthquake and volcanism. And due to earthquake and volcanic activity on the earth crust, the different types of landforms created. Same time, external forces, for example, gradational forces, these are called static forces like temperature and dynamic forces. In static forces, temperature plays a very important role. They try to break the rock at the same place by weathering. And dynamic forces are mainly the agents of gradation like wind, water and ice. They also try to bring everything down by wear and tear and by the process of erosion. Altogether, they try to bring these features down by erosion and weathering. And they give birth to new landforms like plateaus and plains. Now we'll learn about mountains. Nearly 27% of the world land surface is covered by mountains. Mountains are either isolated landmass, for example, in Africa continent, Kilimanjaro is a volcanic mountain. Some mountains are chain or in ranges, for example, Andes in South America, and some mountains are still rising, Alps and Himalayas. These are called the newly fold mountains. They are mainly formed due to the collision of two plates at the convergent boundary. And some are old fold mountains, for example, Aravallis and Ural. Aravallis and Ural are considered to be the oldest mountain chain on planet Earth and their age is considered to be more than 1 billion years. Now we'll understand what is mountain building. Another phenomenon remarkably explained by the plate tectonic theory is the formation of mountains on the Earth's surface. Landmass on Earth's crust more than 900 meters from mean sea level is called a mountain. The process of mountain formation is called orogenesis, and orogeny means period of mountain building. For example, Himalayan mountain ranges are recently formed, or we also call it newly fold mountain. Himalayan mountain ranges are still in the process of rising. As per the geological age, Himalayan mountain ranges are 40 to 60 million year old. There are four types of mountains have been observed on the Earth's surface: fold mountains, block mountains, volcanic mountains, and residual mountains. Volcanic mountains are also called accumulated mountains, and residual mountains are also called relict mountains. Now we'll understand how the fold mountains take birth on the Earth crust. When one plate pushes itself up against another one, the edges of both the plates are intensely folded. These are mainly due to the compressional force. When the two plates collide from both the sides, this force is called the horizontal force of the crustal motion. But due to collision of these two plates, on the top of that crust, the lighter material, mainly sedimentary layers or you can say the rock strata, they tend to get piled up in giant folds. And these folds one is the creased and the lower part is called the throat. Now this process consequently leads to the upliftment of the rock strata. Now what is the meaning of rock strata? Primarily, the sedimentary type or sedimentary nature of rocks, they tend to get piled up. Instead of they get break, they pile up or they get folded, which rise up as a mountain at the plate boundary. Now, because of compressional force, the heavier material sinks down and the lighter material, because of buoyancy, they get piled up or they pushed upwards or uplifted. Now, based on the age of the fold mountains, they can be classified as young fold mountains and old fold mountains. Young fold mountains, examples Himalayas, Alps and Andes. And old fold mountains are Appalachians, Urals and Aravallis. Himalayan mountain ranges are recently formed. They are about 30 to 40 million year old. And old fold mountains are the geological age considered to be 1000 million year old. Now we'll understand with the help of a video clip how fold mountains form. This is a very good example of Himalayan mountain ranges. As you can see the cross-section view, these are the giant folds in the Himalayan mountain ranges. This is a very good example with the help of an animation. Indian plate about 60 million years back collided with Eurasian plate. Due to collision, the soft material rock strata they piled up and they have given birth to the giant folds. Now, these folds are today seen as the peaks of Himalayan mountain ranges. Now we'll understand the third type of mountain called the block mountains. As you can see in the sketch, there's a block mountain has been shown. 1, 2 and 3 blocks have been shown and these two red arrows are representing the horizontal tensional force. Now this force is responsible for the formation of block mountains. We'll understand in detail. Block mountains are created when the block between the two roughly parallel normal faults either uplifted or sinks down. If the crustal block on either side of the two normal fault sinks is called Greban. This is the part which went down is called the Greban and the block which remains uplifted is called the host. Rift valleys are also created when the block between the two roughly parallel normal faults sinks and give birth to massive rift valleys. The best examples are Sierra Nevada in North America, Vosges in France, and Black Forest in Germany. Now we'll understand with the help of a video clip how block mountains form. As you can see a horizontal crustal block, due to the crustal movement it may develop some vertical faults. And these vertical faults are result of tensional force when it's been pulled on either side, and due to this faulting the block between these two will slowly sink down and give birth to a block mountain. This is a visual of the block mountain in Vosges in Europe. As you can see the blocks on either side. There is another example of block mountain formation in India, the marble rocks at Jabalpur. Now we'll learn the third type of mountain called residual mountain. These mountains are formed due to the intense weathering and erosion process. As you can see in the visual, this particular rock boulder or the surroundings are exposed rock. These are exposed due to the intense weathering. Now we'll understand in detail the formation of residual mountain. Due to the effects of weathering as a part of exogenetic forces, as you know that these forces act on the earth crust, mainly the external processes, where dynamic and static agents work on the different features of the landform to bring it down, mainly temperature and the dynamic agents like wind, water and ice. Weathering act upon the earth crust constantly and they try to erode it. Naturally, some portion of an elevated area resists the process of weathering. As you can see in this picture, this place, the exposed rock boulder in the past might have covered with soft rock strata. In the course of time, due to the agents of gradation, the soft rock might have eroded by the process of erosion. But these hard rock boulders, they resist the process of weathering and they still remain, these portions remain unweathered while its surrounding area gets eroded constantly. As a result, the formation of residual or relic mountains. Some of the examples of residual mountains are Nilgiri Hills, Raj Mahal and mountains like Aravallis. Now we'll watch a visual to understand how the relic mountains look like. As you can see in the visual, these are exposed rock boulders. In the surrounding area, this place might have covered with a thick layer of sediments or you can say soft rock strata. In the course of time, by the agents of gradation, the soft rock might have eroded away and this more resistant rock, they get exposed and has given birth to residual mountains. These rock boulders are still resisting the process of weathering. Now we'll understand what are the significance of mountain. Mountains are the storehouse of natural resources. There are pockets of minerals like petroleum, coal and limestone. The best example in the northeastern Himalayas, there is a pocket of crude oil called Dig Boy. There are some pockets of coal also present in the lower Himalayan region, mainly lignite or peat coal. Also, this is the source of good quality timber, lac and medicinal herbs. These medicinal herbs are used for making Ayurvedic medicines. Apart from that, mountainous regions are very good locations for setting up hydel power stations or dams. With the help of this dam, one can generate electricity by releasing the water because these regions are the perennial source of rivers. Formation of fertile plain. India is the best example. Himalayan ranges in India provide unlimited source of water because of melting of glaciers. There are about more than 5 major rivers that flow towards northern India that bring very fertile soil which give birth to one of the largest fertile plains. Mountain also plays as a political frontier. The best example is Himalayan mountain range. It is a barrier between the neighboring countries which protect the country from any intruders. The effect on climate. They serve as a climatic divide. The mountain cause orogenic rainfall. The best example is once again Himalayan mountain ranges. They don't allow the cold Siberian winds to enter into India, and this mountain even doesn't allow the southwest monsoon winds to escape. Mountains are also the tourist centers. There are many locations in the mountainous region that become the hill stations, and during summer, this become the ideal location for the tourists. These are some of the significance of mountains. Now we'll learn about plateaus. As you can see in the visual, plateaus are the elevated areas which is more or less leveled at the top. As you can see, the top part is a flat, and on the either side there is an abrupt drop, or you can say there is a vertical slope on all four sides. They are also called the high plains or the tablelands because the top part is flat. The plateaus cover about 18% of the Earth's land surface. Plateaus are mainly formed due to this process. Plateaus can be raised suddenly on the earth crust due to tectonic movements. The fluvial action is also responsible for the formation of dissected table mountains. Fluvial action means the action of rivers. The rivers eroded the soft part from the surroundings, and the highly resistant rock, it appeared like an exhumed formation, and they give birth to a table mountain. Such formations are also called plateaus. Classification of the plateaus on the basis of their geographical location and the structure of rocks. The plateaus can be classified as Intermontane plateau and volcanic plateaus. Now we'll understand with the help of visual how the plateau look like. The flat top table mountain, the famous Depositional plateau in South America. These are also the good source of waterfall during rainy season. As you can see, this is a dissected plateau. Due to fluvial action, the rocks have been eroded badly. As you can see, there is an abrupt drop on the all side and the flat top table mountain formation. You can see the steepness. Now we'll learn about Intermontane plateau. Intermontane plateau, as the name suggests, that such plateaus are mainly located in the mountainous region. The plateau which is bordered by mountain ranges or mountain, generally fold mountain. As you already learned in the previous topic, fold mountains are formed due to the compressional force. The word intermontane means between mountains, and intermontane plateaus are highest in the world. As you can see in this picture, this flat terrain is a plateau, and this plateau is called the Tibet plateau and surrounded by mountain on either side. Such plateaus are the highest in the world. They have nearly horizontal rock layers which are raised to very heights by vertical movement of the earth crust. The best example of such plateaus are Tibetan Plateau, Plateau of Bolivia, Plateau of Tarim Basin. These plateaus are mainly complex plateaus. They are not formed due to the flow of lava. They mainly formed due to the compressional effect of the tectonic plates, and they're raised very high from the surrounding areas. Now we'll learn about volcanic plateau. A volcanic plateau is a plateau produced by volcanic activity and fissure flow of lava. Fissure flow of lava means the lava that spread from a crack or a fissure. There are mainly two types of plateaus, lava plateaus and pyroclastic plateaus. Lava plateaus are formed by highly fluid basaltic lava. Highly fluid basaltic lava means the lava that can flow very fast during numerous successive eruptions through numerous vents without violent explosion. And such lava, they pile up in layer and layer, and they increase in height and give birth to lava plateaus. The other type of volcanic plateau is called the pyroclastic volcanic plateau. In this, the lava is less and more of debris and rock fragments and dust particles, and they are massive in quantity. They flow, and the layer by layer they pile up and they form a pyroclastic plateau region. Now we look upon the significance of plateau. Plateaus are the storehouse of minerals. Most of the minerals in the world are found in the plateau region. These minerals are mainly metallic minerals. As you can see in this picture down there, the step mining technique or open cast mining, and from this plateau region one can extract huge quantity of metallic minerals. Even the plateau regions are good locations for setting up hydel power stations. The edge of the plateau form waterfalls which provides ideal sites for generating hydel power. The water can be diverted towards a turbine, and with the help of this technique one can generate energy. Cool climate. The higher parts of the plateau regions are cooler climate. For example, in southern India, the Deccan Plateau is relatively higher and the climate is cool. Animal rearing and agriculture. Many of the plateau region have large grassland. They are very suitable for the animal rearing, and this area is very rich in the mineral resources also, and soil is very fertile. Now we learn about the third important landform called plain. The name itself suggests that these are the low-lying areas. They are relatively flat and less slope or gentle slope. About 55% of the Earth's land surface is occupied by plains. Now these plains are the good sites for agricultural practice. As you can see in this picture, most of the plains have been formed by the deposition of sediments brought down by the rivers. Rivers primarily pick up the fine sediments from the hilly region and they deposit in the low-lying areas and that give birth to very fertile land. These lands are very good for agricultural practice. The best example of plain is Indo-Gangetic Plain in India and Wangho Plain in China. Besides rivers, some plains have also been formed by the action of wind, moving ice and tectonic activities. And these are mainly formed due to the external forces, aggradation and the degradation process, where the river plays a very important role, or you can say the agents of gradation plays a very important role. There are two types of plains, structural plain and depositional plain. Structural plains are mainly formed by the upliftment of the sea floor or continental shelf. As you can see in the picture, near the coast, the land has been emerged or uplifted from the sea and due to the tectonic movement. They are located on the edge of almost all the major continents. Such coastal plains become wide due to the deposition of materials washed by the sea wave. The examples are the plains of USA and adjacent to the Western Ghats on the windward side. Now we'll learn the second type of plain called depositional plain. Depositional plain, the name itself suggests that this is formed due to the deposition of fertile soil, mainly brought by the dynamic agents. And these agents are either wind or running water. When wind is the major agent of deposition, they are called the Loess plains. Fine deposit of particles been deposited, Loess plains of northwestern China. And when the plains are formed by the river deposits, they are called the riverine or alluvial plain. As you can see in the picture, it's a large fertile plain and the deposition of sediment has been seen over here. The best example of the plains in the world is Ganga and Brahmaputra plain in India and the Wanghu plain in North China. Thank you for watching the presentation.